Hey, AP Chemsters, this is Mrs. Vanderlei bringing you part 2 of the 4.4 blank wall. And so we left the end of part 1 where it said, how many grams does it take to make this particular solution, which brings us to part 2. How do you actually make this solution? So if I wanted to make this in lab for maybe your next lab or something, how do I make this particular 1 molar solution, 0.2 molar sodium potassium dichromate? So what are the steps? Well, the first step you need to do, here we go, is you need to measure out 58.8 grams of potassium chlorate. That's the first thing. Then what you need to do, you need to place in a clean, dry 1 liter volumetric flask. So I'm assuming that this is my 1 liter volumetric flask. And I wrote, no, the volumetric flasks come in many different volumes. So check the one that matches your volume. So what if this were in a 500 milliliter flask and you grab a 500 milliliter flask? Or if you want it in a 50 milliliter flask, so they're kind of tiny, they're kind of cute there, then you pick out a 50 ml flask. So whatever volume you want to make, you pick out the matching flask. So here, this is what I have. I picked out my flask and I put my stuff in it. All right, so my 58.8 grams of potassium dichromate. Now what do you do? This is we're in part B now. You fill up about half full of water. Why? So then you can shake, shake, shake until all of the solute dissolved. If you filled it up the total volume here and then tried to shake it, it doesn't mix very well. All right, so you want to get all the salt that dissolves or the potassium dichromate to dissolve with about half of the water. All right, and then it says fill the rest way till the meniscus is actually on the etched line. And that's what's showing here. So the meniscus is actually on the etched line. They have a funny looking meniscus. Ours usually curves the other way around. So you want the bottom of the curve to be on the line. Okay, so that's how you make it. Guess what? We're going to be doing that soon, okay? So dilution with water does not alter the number of moles of the solute present. So if I have a given amount of moles in a container to start with, if I add water to it, I still have the same number of moles. What changed? My molarity changed because my volume changed, okay? But my moles remain constant. So let's go back. What is my mountain look like? You're going to sing with me? The moles on top of the mountain. That's right. So here's my moles on top of the mountain. What's moles equal to? Molarity times liters. So what I'm saying here is molarity 1, volume 1, which is my liters, is equal to molarity 2, volume 2. So if I have a given molarity and a given volume and I change the volume, what's my molarity? This also is very handy if you want a certain molarity. You can calculate, well, how much volume does it take to get to that certain molarity. All right, so if you have a starting molarity and you want a certain molarity, you can calculate for V2 to solve for how much do I need to dilute it to, okay? So we have some problems where we're going to do just that. So let's go to the next page. By the way, this is what we just did describe how to prepare the solution. This is not a dilution solution. This is just like the one with potassium dichromate. So basically, I've already figured out how much you have, half a mole. So you're going to weigh out 85 grams of sodium nitrate, put it in here, fill it halfway, shake, 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 fill it up to the top. All right, great. Let's do a dilution problem though, okay? To what volume should you dilute the 0.2 liters at 15 molarity to obtain a new molarity? So you're given an initial volume, that's your 0.200 liters. You have an initial molarity, that's your 15.0 molar, and now you want a 3 molar, okay? So just plug all those numbers in, all right? And then what do you get? You get 1 liter. All right, so why don't you do problem 21 all by yourself? So pause this, set it up, do it. All right, look at what you have. You have a molarity, okay? You know how much original you have. No, you don't know how much your original volume is, but you want to end up with 100 mils and you want to end up with this molarity. So why am I emphasizing this? You do not know volume 1. That's what you're calculating for. How much of the original stuff do you need to make 100 mils of 5.23 times 10 to the -4th molarity? So only use this formula for dilutions. Never use that formula for anything else, okay? Only for dilutions. Did you hear me? Good. Great. Now let's plug some numbers in. We have an initial molarity. I don't know my initial volume. here's my new molarity, and here's my new value. So when I solve for that, there you go. So we're talking about 3.37 milliliters if you convert that. So what does that mean? You take a graduate cylinder or you take out a pipette and you take out 3.37 milliliters of this molarity, you put it in a 100 ml volumetric flask, and you fill it to the line. What does that give you? It gives you a solution with this molarity. So once again, you're going to take this much out of like a stock solution with a given molarity here, you put it in a 100 ml flask, all right, and that's your resulting molarity, okay? So this problem 22 is called a serial dilution. It's where you take a known concentration and you dilute it, and then you dilute that, and then you dilute that, all right? So if I start off with 20 mils of a 2 molar iron 2 thiocyanate solution and you dilute it to 100 mils, all right? What do you think you're solving for? All right, what are you given? You have an original volume, an original molarity, and a new volume. Well, what's left to solve for? Your new molarity. All right, so let's find out what that new molarity is. We go calculate it. So pause it, calculate it. All right, so I put my numbers in and I got my my new molarity of 0.40. Notice that the molarity went down and the volume went up. So notice that this 20 mils went up to 100 mils, so my molarity had to go down, didn't it? Okay, became more dilute. So what happens next? I'm going to take this known molarity now. I'm going to take 15 mils out of the 100, all right? I'm going to take 15 mils out and put it in a new 100 volumetric flask, all right? So what is its new molarity in the new flask? Go ahead and calculate it. All right, so this is what I did. This is what I did here. So I have my my diluted from the original 2 molar to 0.4 molar, took 15 mils out. I diluted it to 100 mils again. What's my new molarity? It is 0.060. Okay, guess what? Let's do it one more time. Let's dilute it again. So from this 100 mils, I'm going to take 30 mils out of it, okay, and I'm going to dilute it into a new volumetric flask, okay? So what's my new molarity? Go ahead and calculate it. Pause if you need. Okay, welcome back. Hopefully you did this. You plugged in the 30 mils from this over here, so that's your new molarity there, and you're going to dilute it to 100 mils again, so my last molarity is now 0.018. So that's a serial dilution, where you keep taking your new amount and diluting it again. Take your new amount and dilute it again, okay? This last problem ties in the last several sections, so let's see what we're going to do. It says, in what volume of a 0.15 molar solution will completely react with 35.7 mils of a 0.108 molar sodium carbonate solution according to the equation below? Hey, what's the first thing you ought to do? Hey, why don't you balance it? Go ahead and do that. Well, this is what I got. I don't know if that's what you got. And I'm going to be setting up a BCA table, isn't it? Because they're asking you for one quantity to react with another quantity. Okay, so what do you know everything about? I know sodium carbonate, I got molarity and I got volume. What can you solve for if you have molarity and volume? I can solve for moles, all right? So I can solve for moles. Let's do that. So moles is equal to molarity times volume. I'm going to do it up here because I got some room up here. And my molarity is, here we go, and that gives me how many moles of sodium carbonate? 0.00386, all right? So I'm going to put that right here. So I don't have to have grams to fill out the BCA table. I can have solutions, all right? And I'm going to completely react all this up, so I don't have any left over. All right, that's what it means by completely react. Well, what is it completely reacting with? It's completely reacting with the nitric acid. So what does that mean? I need all this to cancel out. Well, do you remember what we do? Take this divided by 1 times 2, right? So take that divided by 1 times 2. Well, it's all going to, I want 0, right? So this is how much I start with. What is this unit right here, 0.00772? That is a mole. So now I want liters, right? What volume? And well, I have to start with liters though. I have molarity. Guess what? I now have moles. I can calculate molarity, or I'm sorry, I can calculate liters now, can't I? So here is my liters, and they asked for milliliters. So that's it. We're going to practice some more of those next time we meet. So like I always end with, don't wait to be great. Bye, everyone.